security and operations folks sort of collaborating on these profiles to sort of get everything met. Because there's so much, and so much of it changes sort of all the time.
Hi, you're listening to The Secure Developer. It's part of the My DevSecOps community, a platform for developers, operators, and security people to share their views and practices on DevSecOps, Dev and Sec collaboration, cloud security, and more. Check out mydevsecops.io to join the community and find other great resources. This podcast is sponsored by Snyk. Snyk is a dev-first security company helping companies fix vulnerabilities in open source components and containers without slowing down development. To learn more, visit snyk.io. On today's episode, Guy Podjarny, president and co-founder of Snyk, talks to Mandi Walls at DevSecCon Seattle. Mandi is a technical community manager at Chef. For Chef, she helps technology organizations increase their effectiveness using configuration management and modern IT practices. She is a regular speaker at technical conferences and is the author of the white paper, Building a DevOps Culture, published by O'Reilly.
Hello, everybody. Welcome back to The Secure Developer. Today, we have another DevSecCon special edition version of The Secure Developer, and we have with us Mandi Walls from Chef. Welcome to the show, Mandi.
Hey, thank you.
So, Mandi, before we kind of dig into the topics of the talks and all that, tell us a little bit about yourself. What is it that you do?
Yeah, so I am a developer advocate, technical community manager at Chef Software. I've been at Chef a number of years doing different things. Chef, if you're not familiar with the company, we started out doing infrastructure security and automation, and now we have products to do security automation and application automation, some other things too. So
yeah, well, definitely one of the sort of the pioneers of sort of infrastructure as code and kind of modern, I guess, release management.
Absolutely,
right?
Yep.
So, Mandi, what is your talk about? We talk about InSpec.
Yeah, so we have a product called InSpec that we originally purchased a company a number of years ago. They had been working with some larger companies in Germany to do infrastructure security testing for like code, the infrastructure as code part. But the tool itself is pretty flexible, so that my talk was mostly about using it in isolation to actually dig into your hosts, your infrastructure hosts, whether they're virtual machines or whatever they are, and dig around in there and see what they're doing and if they're violating your security policies or any of those kinds of things. So files that are owned correctly or packages that shouldn't be installed, or there's kind of mundane, boring security things that like every sysadmin has had to do and probably has like a set of shell scripts to do them. But InSpec tooling gives you something more robust to deal with.
Is this something you'd like install on the different machines? So like you'd put the InSpec agent, I guess?
Yeah, you can put an InSpec agent on. You can run it inside your other configuration management software, or you can run it remotely, like as an on-demand sort of scan. So it's pretty flexible that way.
And this would work in which surroundings would it work versus not? Is it like a more VM machines?
Yeah, you can run it against VMs. You can run it against Docker containers. It's focused on Linux and Windows. There's like stuff right off the shelf for most major Linux distributions, as well as sort of the modern Windows releases. So
okay. So let's kind of, go up a little bit in the picture. So you've gone along, you've put InSpec in all the different sort of portions of your servers, right? Or sort of in a good enough portion to care. And then what happens? So you have those agents, and then how does it work? Does it funnel data somewhere?
Yeah, you can funnel data places. It has exporters. You can run it in a JSON and collect it yourself, or you can hook it into some of our other products that allow you to sort of centrally manage it. It gives you a variety of ways to, like, if there's a new vulnerability, you can push out a new test and just sort of automatically collect information back off of your estate to say, all right, well, now I know this thing came out yesterday. Here's how I tested it. I know that 45% of my fleet is vulnerable to this, and you can sort of schedule from there what you want to do to remediate that. So it gives you a lot of faster ways of implementing a security check across stuff at that sort of level.
Got it. So I have a whole bunch of tangents of paths to take down with questions. Let's sort of try to sort of shoot them down one at a time. So first of all, maybe let's sort of back to maybe the value proposition. So what types of questions, now you have this sort of new, data perspective at your fingertips, and you mentioned one example, which is, you want to answer what vulnerable component or what component, where might it be present?
Yeah.
I guess, can you give us maybe some other examples of what's done there? And in general, do you see this as more kind of more inspection or more action, or am I even asking the right question?
Yeah, we're kind of like, it partners really well with configuration management software such that you can establish a baseline and then work towards, fulfilling that baseline. So it's kind of like, you can sort of take a test-driven development approach to it, say, here's my security requirements based on these tests. Mm-hmm. And it functions, the spec part of the name kind of gives it away a little bit. It's based off of like spec testing from Ruby in particular, right? So something like RSpec, which gives you this sort of predictable behavior-driven sort of testing model where I can say, I want this package to not be installed, or I want this service to not be running. And you can sort of push that stuff all out across all of your platform. So it gives you that sort of capability to say, here's my baseline, whether I am working against the CIS profiles or NSA profiles or any of these sort of recommendations that when you look at them, they're massive pieces of information. Like CIS for RHEL is like 500 pages of PDF. And like distilling that down into code that my security engineers understand it fulfills their requirements. I can put enough comments in it, descriptions that my compliance people who may not necessarily be, as technically savvy, their job is more on the compliance side, they can figure out what's going on there. And then my operations folks, my DevOps, my developers, and other engineers can say, all right, I can see what this is doing, what it's testing against, and I know I can't violate these particular sets of rules. And it gives sort of everybody one place to document and have their sort of requirements met in one set of tools. And I can save them on GitHub and I can pass them around and people can consume them whenever they need them. So in that way, it gives you sort of a unified but very flexible approach to the infrastructure layer that way.
Kind of, the being able to just asking code so you can ask it at scale. So how does this work in containers? Containers, I guess two differences come to mind. One is just the short-lived nature of, containers are these machines that don't stick around for that long if you do it well. Yeah. And then the second is the definition area. Like, where are they defined? Oftentimes it's at the hands of developers, right? You edit some Docker file, you change it, as opposed to those ops people and also the DevOps teams that run it. How is InSpec used in that context?
A couple of ways. You can actually attach directly to a running container and dig around in there the same way as you would with a running file. You can also attach is it daughter containers or what the sidecars to also run in your instance if you're expecting that container to be a little bit longer lived. The same sort of thing, because like some of the tests can be a little bit more abstract. It's not necessarily the lowest level stuff. You can also run tests against the configuration of a service. So you can interrogate the http.conf file or your nginx.conf file. And those are things that they're still going to be running. You can run them in your container. That's perfectly acceptable. But you still want to be able to interrogate those and make sure that they're configured correctly, even if they're going to be in the container.
Yeah.
So,
Okay, got it. So, fundamentally, this is one area where containers are very much VM-like.
Mm-hmm. Absolutely, for those services.
Does it even make sense to think about this in the context of serverless?
I'm not really sure that it does. I mean, somewhere somebody is running a platform underneath that. So like your provider, you would hope would have some kind of...
The underlying, not for the functions, but the...
On the substrate somewhere.
Yeah. Oftentimes containers, once again, right?
Absolutely.
Yeah. But in that case, it might indeed be sort of the ops teams that are still running kind of that containers. The other thought that comes to mind is more about people. So who gets the alerts? Like if you have a non-compliant system, and doesn't correspond to the spec, who is told about this? Yeah,
I mean, that's something that we kind of see people do all kinds of varieties of things, depending on how they're handling their reporting, whether it's coming to one of our components or if they're shipping it off to something else. Like different subscriptions can happen. If something that highlights into the Automate server, it'll give you red, green. Like that's our product that sort of pulls this stuff in. And, anybody who has sort of access to that server can investigate that and see what's going on. And then other places we've seen folks do, it still goes to the operations people primarily as the first sort of report, and then sort of rolls back up through whoever requested the test or, was sort of responsible for it in the first place to see, because you can remediate something right away, or you can say, we accept this risk and we're okay with this right now. And you can sort of skip it. So it's still in the code, but you're not reporting on it anymore. So you can say, well, we're going to accept this for now. And and move on.
Do you think that over time, this is something that would come into sort of the realm of more the realm of developers? I mean, as you think about, more and more, under the mantra really of DevOps, but also just in practice, more responsibility around operating your system falls to the developers. Do you think more of these alerts should come to the developers as the org matures?
I would hope in an ideal maturation, right? A lot of this stuff I think would get caught during integration testing, because some of the stuff on the infrastructure, the things that you're sort of violating are going to be like ports that shouldn't be open, or they're doing the wrong thing, or services that aren't supposed to be functioning or are misconfigured, or things like that. Because of the flexibility of InSpec as a tool itself, you can run it pretty often. It's fairly quick. So what we would hope to see is that it's going to run in production just to make sure there's no drift and configurations and things like that. But at the same time, we run it in integration, so your developers can say, oh, this change I requested for this particular configuration violates the security policy, and they can see that before their stuff even gets to production. And some of it can be seen like almost as soon as you check in the code, depending on what they're working on. Maybe they've changed a JAMX setting or something weird that folks aren't allowed to do. I mean, you can catch that right away.
Got it. All of this is really independent of sort of Chef, the configuration manager.
Absolutely, it runs independently.
Yeah,
so.
I mean, clearly that's a good way to sort of address the remediation side of it. Hey, I just found an unpatched system, can I trigger some automated patching? But it's not, it's independent of it. You can do it anyway. I believe that Netflix, like in one of their sort of simian army, has this thing called a conformity monkey that basically goes around and finds
drift, I think.
Sort of drift from conformity. Is this along the same lines? Like, are the best practices from there things that you could apply with InSpec as well?
I would expect so. I mean, I think the key parts that we were sort of going after were the readability and the flexibility to sort of allow everyone who has a stake in your security process be a participant in the whole process. Because part of the stuff that we see with infrastructure security is a lot of it's very boring and a lot is very repetitive. So that's great stuff to automate, but your systems administrators on the front line don't necessarily know 100% of the coverage that they should be doing.
Well, I mean, I think just knowing what's around, it's one of those problems where doing it on a single server is easy. Doing it on 10,000 of them.
Put your laptop in production. Let's do it.
Yeah. Not an enticing proposition. And I guess when you think about this from, when you cast your eyes to the future, right? And you think about maybe more containerized or orchestrated surroundings, how do you see InSpec fitting into that future reality? Does it just work the same? There's still an underlying machine and it conforms it? Should there be an InSpec for at the app level if the OS is lower?
I mean, I think we don't have any current plans for that, but as far as like the actual underlying technology under InSpec, the stuff that's under there is Ruby based, and there's a lot of built-in matchers. There's already a lot of libraries there for, looking at the components that you would normally investigate. And over time, it's not beyond the realm of possibility that it would be able to help you with, checking for, have you checked all of your inputs in certain functions and like the additional AppSec sort of things. Whether it would be the best tool for that based on what's already out there is hard to say. But for anything that has an actual running operating system on it, whether it's your container or there's enough stuff going on in the container to sort of approach that, or looking forward into like smaller footprint for IoT and like all those kinds of things, like there's definitely a place there for is to continue to investigate these sort of infrastructure issues, even when the infrastructure is very tiny from that sort of perspective. So
this is sort of about the future. One of the things I like about sort of using InSpec, in this context is that it's the same tool that, really grew up in the ops world, but we're talking about a security utilization to it, and I'm kind of I like to geek out or sort of, I always like it when when you talk about the future of security in DevOps terms. Do you see in practice, like when people write a spec or when they run through it, is there a difference between a security need and a operational need? Is it the same person that generally gets it?
Actually, what we see is a lot more cross-team collaboration on these sorts of things, where one of the speakers mentioned this morning that you often see teams where you have maybe 100 developers and 10 ops people and one person whose job is primarily security. And that's not unusual. We see that with customers all the time, ratio, right? And, part of that becomes, your ops folks have a certain realm that they're super familiar with. If they're sysadmin for any given length of time, they're probably familiar with some of the CIS standards, and they know sort of baseline, the things that they want to check when you instantiate a new system or new container or whatever, like you're looking for specific things. And then the job of the dedicated sort of security person sometimes is the things that fall to them are like vulnerabilities that come from your upstream providers. They're maybe watching mailing lists or cert releases or things like that for specific vulnerabilities, and they sort of apply their expertise in that fashion. And the good part about, an InSpec profile that you can sort of build up over time is that it can include all of those requirements and sort of like work for everyone in that sort of space. So we see a lot more. What we wanted out of configuration management, I think, years ago when we first started doing these things was that engineers, application developers, operations people would all sort of collaborate on the configuration management software. That didn't really happen most places. Like, there was never enough of an impetus for the application engineers to sort of participate in that. But we see a lot more security and operations folks sort of collaborating on these profiles to sort of get everything met, because there's so much, and so much of it changes sort of all the time, that you want to be up on as much as possible and bring in everybody's expertise when you can.
So. It makes perfect sense. And, I love that very much. I think a very repeated theme, across sort of the episodes here that as we've been sort of talking to people running modern security teams, is this notion of reuse of the tech. But really, reuse of the tech just exemplifies the reuse of the practice, right? And the knowledge, and embedding a security question, a security practice into just sort of daily operational or development, depending on the sort of security threats.
You want to make it as easy as possible. If it's going to be part of your build process to check your substrate before you deploy, it has to be super fast. You don't want to be waiting on it. You don't want to be blocking your builds, any of those kinds of things. So, yeah.
Well, this sounds super useful for people to check out. I assume, kind of like most stuff out of Chef, there's an open source path and there's a commercial path if you prefer.
This particular product in particular has a really lively open source community. They're global. Like, there's folks all over the world using this and working on it. So in addition to our employees, there's a number of folks in the open source world, and they're always, sort of open for
building more of those specs and evolving this.
Right? There's a lot of stuff out there. So.
Very cool. Well, Mandi, thanks a lot for coming on the show and sharing these perspectives, and we'll put links to the YouTube video of the talk.
Oh, excellent. Great.
And thanks everybody for tuning in, and I hope you join us for the next one.
Thanks for listening to The Secure Developer. That's all we have time for today. For additional episodes and full transcriptions, visit mydevsecops.io. If you'd like to be a guest on the show or get involved in the community, you can also find us on Twitter at mydevsecops. Don't forget to leave us a review on iTunes if you enjoyed today's episode. Bye for now.